So now I want to look at composite functions. What are composite functions? A composite function is the application of one function to the output of another function. What exactly do we mean by that? Let's say we have a function. Let's say we have a function f of x equal 2x plus 5. Let's say we have another function that says g of x is equal to 4x minus 1. I'm going to look at this two different ways. Let's say I ask you to calculate fg of 2. So this can be done in one of two ways. So a composite function is the application of one function to the output of another. So let's find g of 2. This is me, by the way, we always work from the right to the left, right? Let's find g of 2. G of 2 would be what? G of 2, let me find g of 2. G of 2 will be, you put 2 into g, right? Replace the x with 2. So g of 2 would mean 4 times 2, which is 8, minus 1, which is 7. So g of 2 is 7. Alright, so the output of this, so this thing here, when you plug 2 inside, you get 7. So the output of this is 7. So you apply f to the output of g of 2. So you apply f to the output. What's the output? What's g of 2? G of 2 is 7. The input is 2, right? And of course the output is 7. The input is 2, the output is 7. So you're applying the function f to the output, which is 7. So you're applying f to 7. Alright, so you plug in 7. The output from this was 7. You plug it into the function f, which means that f of 7, you're replacing the x with 7. So f of 7 will be 2 times 7 plus 5. And 2 times 7 is 14. 14 plus 5 is 19. So that's what we mean when we say the composite function is the application of one function to the output of another. Now the output, so we apply f to the output of g of 2, so to speak. So g of 2 gives us an output of 7. And then this 7, we apply f to it. And we end up with 19. Alright, by plugging 7 into f, we get 2, 7, 14 plus 5. No, that's one way to look at it. That's one way to do it. Let's do it another way. Now, another way to do this problem is to find the composite function first. Alright, fg of 2 you're asked to find. So find the composite function fg of x first. And how are these functions found? We substitute one function into the other. So you substitute the one on the right into the one in the left. Alright, work in the reverse. So you substitute g into f. What do we mean by substituting g into f? So here's f. F is 2x plus 5. We're going to put g into f. What we mean by saying we put g into f? It means that in f, we're going to replace the x values with 4x minus 1. So we plug g into f, meaning we're going to replace the function, we want to replace the x with whatever the function is. In this case, 4x minus 1. Alright, so it's like we're finding f of 4x minus 1. Now here's f of x, 2x plus 5. So you're finding f of 4x minus 1. So for example, suppose I ask you to find f of 10. How will you find f of 10? You'll replace the x with 10, don't it? What if I ask you to find f of 4? You replace the x with 4, right? F of 3, replace x with 3. F of this, replace the x with this. So f of this, you replace the x with whatever is in the bracket. So 2 times x becomes 2 times whatever is in the bracket. And you're done. If you wish, if you're asked to simplify, you can always expand the bracket. Expand the bracket, we get 8x minus 2, so 2 times each term, plus 5. And then this becomes 8x, negative 2 plus 5, that's positive 3. So this is a composite function, fg of x. And then you can always, now fg of 2, replace x with 2, you get 8 times 2, 16, 16 plus 3, 19. Alright, so this would be equal to 8 times 2 plus 3, which is 19. Let's clear and look at some others. So let's do part B now. So this is g f of x. So this means you put f into g. What is f? F is 2x plus 5 over 3. Alright, so you put that into g, meaning in the function g, you're going to replace the x with whatever is in the bracket. Because it's like you're finding g of something, right? So you're going to replace x with whatever is in the bracket. So this becomes 2x plus 5 over 3. That's a term by itself. Plus your 4. And that's it. Now if you want to bring everything under one common denominator, you can write the 4 as 4 over 1, right? And then you want the denominator to be 3, so times 3. You have to do the same thing here, times 3. So what you have is 12 over 3, which is still 4. 12 over 3 is still 4, right? So you have one denominator of 3. And then you can group the numerators now, since you have a common denominator of 3. So it's 2x plus 5 plus 12. And what's 5 and 12? 5 and 12, that's 17. So if you wish, you can rewrite the function, the composite function, as 2x plus 17 over 3. Now in part C, fg of 1, which one of these would you use to find fg of 1? You are correct, fg of x. So fg of x, so g of 1 means you replace the x with 1. So it's 2 times 1, that's 2, plus 13 over 3. And 2 plus 13 is what? 15. And 15 divided by 3 is 5. This is just one way to get it. The other way to get the answer for fg of 1 is to find g of 1 first. Now if you notice g of 1, if you come up here, g of 1 is 1 plus 4, 5. And after you find g of 1, you put it into f. Alright, this you put g of 1 into f. If you put g of 1 into f, g of 1 is 5. If you put 5 into f, you have 2 times 5, which is 10. 10 plus 5, 15. 15 divided by 3, 5, which is what you have here. So it's an alternate way to work part C. So here we have another problem that we want to look at. F of x is 4x minus 7, and g of x is 3x plus 1 over 2. What is g of 0 plus g of 5? Now, g of 0, you come to g, replace x with 0, you get 3 times 0 is 0 plus 1, so it's 1 over 2. And g of 5, you replace x with 5, so 3 times 5, that's 15. 15 plus 1, that's 16. 16 divided by 2, that's 8. So half plus 8, that's 8.5, right? fg of x. So fg of x, let me do part B down here. fg of x mean you put g into f. So f, what is g? G is 3x plus 1 over 2. Alright, so g is 3x plus 1 over 2. So you put g into f, meaning in f, you're going to replace the x with whatever is in the bracket. So this becomes 4 times the bracket minus 7. And that's it. In part C, we are asked to find fg of 5. In part C, let's separate this. We are asked to find fg of 5. fg of 5 now mean so this is fg of x, right? So you're going to replace the x with 5. So we have 4, bracket. Now we are replacing the x with 5. So 3 times 5, so this 3 times 5, that's 15. 15 plus 1, that's 16. So what you have is 16 divided by 2, minus 7. So again, you're replacing this x with 5, fg of x, and you're finding fg of 5. So you replace the x with 5, so 3, 5, 15. 15 plus 1, 16, and it's 16 over 2. Now, 16 divided by 2, that's 8. 8 times 4 is 32. So what we have is 32 minus 7. Now it's 32 minus 7. That's 25. So the solution for part C is 25. The other way to do part C is to find g of 5 first. G of 5 will be 3 times 5, 15. 15 plus 1, 16. 16 divided by 2, 8. So g of 5 is 8. And then this output of 8, you apply the function here to it. So you apply this function to the 8. 4 times 8, 32. 32 minus 7. You will get the same 25. So either way is okay.